Hello everyone, dear friends. In this course, we are going to talk about Docker and Kubernetes. In recent years, the use of Docker has increased greatly and has become a popular tool. First, let's talk about what Docker is and what it is used for. So, to avoid writing and save time, we'll go to Google Gemini and ask it to give us an explanation about Docker. Docker is a tool that allows developers to package an application and all its parts, code, libraries, settings, into a single, standardized unit called a container. This ensures the application runs exactly the same way, regardless of where it is running, whether on your laptop, a colleague's machine, or a cloud server. The concept of a container is similar to a shipping container. Before shipping containers, moving products was not easy. You have to think about all aspects of the product, such as the dimensions and shape of the product, and even the requirements of each product, such as whether a product needs to be cold or hot, or has specific humidity conditions. The Docker mechanism is such that it presents the application with all its requirements, such as the application source itself, the required tools and libraries, in the form of an isolated package that can be run in any environment without problems. The next important concept in Docker is a file called a Docker file. This file is an instruction for building the initial version of a container. But the next important concept in Docker is the image. An image is like a blueprint. When a Docker file is run, an image is built based on the instructions in it. This image is a read-only version of your application from which we can only build different versions of the application. But the next important concept in Docker is the container. A container is like a house. The output of a run is a container image. A container is a live environment that your application runs inside. Here he talks about the difference between Docker and virtual machines. A virtual machine, VM, and a Docker container differ mainly in how they virtualize computing resources and how lightweight they are. A virtual machine runs a full guest operating system on top of a hypervisor, along with its own kernel, libraries, and applications, which makes VMs more isolated but also heavier in terms of resource usage and slower to start. In contrast, a Docker container virtualizes at the operating system level and shares the host system's kernel, packaging only the application and its dependencies, which makes containers much smaller, faster to start, and more efficient. While VMs are well suited for running multiple different operating systems on the same hardware, containers are ideal for deploying and scaling applications quickly and consistently across environments. But let's look at a real-world example to better understand these concepts. Let's say you want to set up a web server. You first need to download, install, and configure the web server installation file. Then you need to manage permissions. You also need to worry about making sure it doesn't interfere with other applications. But in Docker, you build the web server image with a command line and then you can build and run the required container image. That's enough explanation for this part, and we will continue the Docker discussion in the next video. See you next video.